Okay, so all I want you to do here is find the critical numbers. So we're just going to get some practice with step 1 of this. What are the critical numbers? Well, if I say find the critical numbers, I mean take the derivative of the function, set it equal to 0, and solve. Or take the derivative of the function and find out where it does not exist. Okay, so f prime at x. A cubic function, we can do this. 3x squared plus 12x plus 9. And if I want to find the critical numbers, I'm looking for the zeros. Where is this equal to 0? Well, let's factor this. We would get 3x squared plus 4x plus 3. Oh, that factors easily as x plus 3 and x plus 1. And since I'm using this, I'm going to check my work. I got the 4 and I got the positive 3. Okay, so where does f prime equal 0? F prime is equal to 0 if x is negative 3 or negative 1. These are my critical numbers. And I'm going to put them in a set like that, like with those squiggly brackets, so that you don't mix it up with an ordered XY pair. Okay, so critical numbers, and if I wanted to know if it was a max or a min, then there's a little bit more work that I would have to do with that. Critical numbers for f prime for absolute value x, we just did this on the other page. F prime at x is equal to 1 when x is greater than 0, negative 1 when x is less than 0. So f prime at x does not exist if x equals 0. So what's my critical number? 0. Okay, so once you can find your critical numbers, then we're going to test them and see if they're giving us a max or a min. So here's our closed interval method, and as the name implies, or clearly states, it has to work, it only works on a closed interval. So to find the absolute maximum and minimum values of a continuous function on a closed interval, we find the values of the function at the critical numbers. In the open interval, we find the value of the function at the endpoints, that is at a and b, and then we just decide which one's bigger, and we call that the biggest, and which one's smaller, and we call that the smallest. Okay, so for this question that we just did up here, we had critical numbers. So f prime at x was 3 bracket x plus 3 bracket x plus 1. And we found that we had these critical numbers at negative 3 and 1. So we need to find the values of the function at those critical numbers. So I'm just going to list them. They were at negative 3, negative 1. Then we need to find the values of the function at the endpoints. So the endpoints of that closed interval, negative 3.5 and positive 1. Okay, so let's just set up a t-chart then. So I want to know what's the minimum value of this function on that closed interval and what's the maximum value. So it might happen at the endpoint, the beginning or the ending. Just like in our example, when we warmed up here, we did have an absolute min at an endpoint. Okay. So it might happen at an endpoint, or it might happen partway in between, where our derivative was 0. And those are the only possible options we have for finding a max or a min. So let's just test it. If I put negative 3.5 into this function, plug it in your calculator and tell me, what is negative 3.5 cubed plus 6 times that squared plus 9 times that plus 2? And if we're going to do this a couple of times, then I'm going to program it into my equation editor. Okay, so there it is, and then I want to know the values at all those points. So I need it at negative 3.5, at negative 3, at negative 1, and at positive 1. Okay, so the values I'm getting, the function would be 1.125. At negative 3, I get 2. At negative 1, I get negative 2. And at 1, I get 18.